We're going to be going over pointers to structures. So we may take the address of a structure, like something that we have up here, this struct rectangle. We can take the address of it and create variables that are pointers to this structure. So let's make an instance of our structure first. It's going to be a rectangle, and we'll just call it R initially. Let's also make a pointer to this. So we're going to make a rectangle, and then we'll have a asterisk, and then we'll have R for rectangle, and then a P just to show that it's a pointer. If you wanted to, we can set it equal to the address of this rectangle, and that's totally fine. Or if you don't know what you want to set it to yet, you can set it equal to a null pointer. This should be a lowercase p. So you can either set it to R or a null pointer if you want to set it later. This statement defines the R pointer as a pointer to a null pointer, but it's going to eventually point to a rectangle. So let's fill in the values of this rectangle. We could either do it manually, or we can call this method that I made in the previous video. So we're going to do R is equal to new rectangle, and that's just going to have all of its current values filled out with the ones inside of here. So that's going to be our rectangle. From here, we can take the R pointer. So we'll do R pointer, and we'll set it equal to our address of R. So R pointer now points to said address, and now it points to the rectangle structure that we made. Now let's dereference this so we can print the values using the R pointer. To do this is actually pretty interesting. Instead of doing the asterisk to get the element, since it's a pointer to a structure, we're going to have our R pointer, so whatever our pointer is called, without the asterisk, because that'll get the address. We have it pointing to whatever, literally pointing to whatever value we're trying to get. So if we're trying to get the length, it's going to point to the length. If we're trying to get the width, it's literally going to point to the width. And then if we're trying to get the area, it's literally going to point to the area. And if we run this, you can see it's going to print the area, which, given the length and the width, not modified, it should be 100. However, you can also modify this. So to modify a member that a pointer is pointing to, all you're going to do, let's say we want to do for the area, we're going to do R pointer. It's pointing to the area, and we're going to set it equal to, and we can set it to be like 200. Let's finish the run here first, Replic's being a little bit slow, and you can see it'll get 100. Let me run this again. So that's how we could update based on a pointer. So that's how we would print something out. That's the actual dereferencing part, dereferencing our structure pointers. And then this part up here would be dynamically allocating a structure. So whenever you assign something like this, you're dynamically allocating a structure with the pointers, and if you use a pointer to print something, you're dereferencing our structure pointers. So dynamically allocating and dereferencing. That's going to be it for this example. In the next one, I'll do a short example of how to dynamically allocate an array of structures. If you have any questions on the material, as always, leave a comment below, and if you want more C++, check out that playlist linked below the like button.